So, picture this. One part of a region is overflowing with water, while another part, not too far away, is bone dry. What do? Well, it's a huge challenge, and for the Indian state of Karnataka, it's just a geographic fact of life. But what if you could just move the water? Okay, let's dive into this absolutely massive engineering plan that's designed to do exactly that.
Just take a look at this map from the National Water Development Agency. It really tells the whole story, doesn't it? Over there on the left, in the west, you've got the Bedti River basin. It gets hammered by monsoon rains, and the rivers flow right out to the Arabian Sea. It's flush with water. But then you look to the east, and it's a completely different picture. It's much, much drier and often struggles with drought. So you see, the problem isn't that the state doesn't have water, it's just that there's this huge imbalance in where it's located.
And that brings us to this incredible proposal, the Bedti Hirevaddatti Link Project. We're going to be looking at a specific version of the plan called Alternative 2. This is an unbelievably ambitious idea to basically re-engineer the region's entire water destiny, creating a brand new connection between the water-rich west and the thirsty east.
Now, this is the really crucial point to get. The project isn't about stealing water that's already needed in the west. No. The whole idea is to capture only the surplus water, the extra stuff, that comes down during those 5 super heavy monsoon months, from about June to October, and move that to where it's desperately needed.
And we are talking about a truly colossal amount of water here, 524 million cubic meters, every single year. To try and put that into perspective for you, that's enough water to fill up more than 200,000 Olympic-sized swimming pools. Every single year. It's just a mind-boggling volume.
So how on earth would they actually pull this off? Let's take a look at the blueprint for this incredible feat of engineering. It really breaks down into 2 main parts. First, you've got to collect the water, and second, you've got to move it.
It all kicks off with what engineers call the headworks. Now, don't let the technical term throw you off. You can basically think of them as giant funnels and control tabs right there at the source, designed specifically to capture all that surplus river flow before it just runs off into the sea.
So for this project, the headworks are made up of 3 key structures. You have 2 weirs, the Pattanadahalla and Shalamalahalla, which are kind of like low dams that help raise the river's water level. And then there's a bigger structure called the Suremane Barrage. The whole system, all 3 of them working together, is designed to capture that target of 524 million cubic meters of monsoon water. Okay, so you've collected all this water. Now what? Well, you've got to move it, right? And that is where the conveyance system comes in. Think of it as the project's circulatory system, a massive, sprawling network built to transport all that water from the Bedwater Basin heading east. And when I say massive, I mean it. We're talking about a water superhighway that stretches for nearly 179 kilometers. And remember, it has to cross the Western Ghats mountain range, which, believe me, is no small task. Now, this is where it gets really, really interesting. Look at the complexity of this journey. It's not just one big, long pipe. For almost 134 kilometers, the water will flow downhill through pipelines just using gravity. But it also has to go uphill. For over 36 kilometers, huge, powerful pumps will have to force the water through pipelines to get it over the hills. And to get through the mountains, they'll have to blast and bore nearly 8 kilometers of tunnels. It's an absolute marvel of engineering. All right, so all of that incredible engineering, it's going to come with a pretty significant price tag. But the whole point is to unlock even greater benefits. So let's crunch the numbers and see how the costs and benefits really stack up. The total estimated cost for this plan, Alternative 2, is over 9,652 crore rupees. I mean, that is a monumental investment, and it really reflects just how complex and huge this project really is. So where does all that water actually end up? Well, according to the plan, it's very carefully divided up. The lion's share, 316 million cubic meters, goes straight to irrigation to support farmers. Another 131 million is earmarked for industrial use, and a crucial 77 million is set aside for domestic drinking water. For the farmers in this region, this is an absolute game changer. The project is designed to bring reliable irrigation to over 70,000 hectares of land. That's an area roughly the size of Singapore. We're talking about transforming dry, rain-dependent farms into productive, year-round agricultural land.
And the impact on people's lives is just as huge. This project is set up to provide a secure drinking water supply for over 2 million people, spread across 7 different districts. That takes care of one of the most basic,
most critical human needs you can think of.
Now, this number here, 1.78, is what's called the benefit-cost ratio, and it's a super important number for any project like this. It's actually pretty simple. It means that for every single rupee they spend building this thing, the project is expected to generate 1 rupee and 78 paise in economic benefits, things like more crops, more industrial growth, and so on.
So, when you zoom out and look at the whole thing, the Bedti Hirevaddatti Link isn't just about building pipes and pumps. It's really a strategic vision for the long-term water future of North Karnataka.
At the end of the day, the ultimate goals are crystal clear. First, achieve lasting water security. That security then becomes the fuel for boosting agriculture and supporting new industries. And when you do all that, you directly improve the quality of life and the economic future for millions of people.
Honestly, this quote from the pre-feasibility report just says it all perfectly. It's not just about infrastructure for its own sake. It's about laying a foundation for genuine prosperity and economic growth for the entire region.
And all of this leaves us with a really fascinating question to think about. As our climate continues to change and water becomes an even more precious resource, are these kinds of huge interbasin water transfer projects the key to securing our future? It's a pretty powerful idea to consider.